Or restream wishes Yash on my account. I don't know. I'm not able to get rid of it. We should be live in a minute. Yes. Yash, you can start. You're good. I can't. Yash, you are on mute.
Hi everyone, welcome to weeklywed. Weeklywed is our happy place to share, learn, discuss, and explore. Weeklywed occurs every Wednesday at 9 a.m. Pacific time, and I'm your host Yashaswini Vishwanath, and you can call me Yash. I'm logging from Bangalore, and I would like to know where you're all from. Please type away your name and place in the chat. We would like to get to know you better. And you can also put in your key interests in AI, AV, and IoT, and how you would like to use this information in order to gain more betterment in your career or in your studies. I'm an AI researcher who focuses on responsible AI. I'm also pursuing my master's in artificial intelligence from RAISE. At weeklywed, we empower and enable the audience to break into AI or to explore more of it. Generally, we host speakers from varied backgrounds working on AI and allied technologies. But today is a very special session where we have Sudha, who will be teaching us about autonomous vehicles and foundation models. So, Sudha Jamthe is a technology futurist instructor at Stanford for AI, AV, and IoT. Sudha Jamthe is the founder of Business School of AI, and weeklywed is brought to you from Business School of AI. And Sudha is here with her immense knowledge that she comes with and experience over the last 2 decades. And Sudha, we are all ears to listen to you and learn from you. Over to Sudha.
Thank you so much, Yash. Thank you so much. It's just amazing. The energy with which you open weeklywed is just unbelievable. Awesome. And I see some of my favorite students here, so that makes it easy for me. So it's wonderful for me to come see my students here. And now we are live streaming at YouTube, Twitter, and LinkedIn. So some of you might be just joining from there. So wherever you are, you can add a comment. I will definitely go on to LinkedIn and share all the links. And I will come back and check on Twitter and YouTube also. And all the links that we are sharing, typically I will come back and put it in the newsletter. So I'm Sudha Jamthe. I'm a technology futurist. I'm joining you here from Silicon Valley. And since many of you are my students, you don't need much of an intro, but I also see some new faces. So I thought I would give you some background. And today, I'm here to talk to you about foundational AI models in autonomous vehicles. And you might wonder, what is foundational models? We covered that in the last couple weeks. And I'm going to do a little bit of, dipping into foundation models so that we are all on the same page. I'm expecting to keep this interactive. So Weekly Wednesday, as Yash says, is our happy place, and we have our speakers coming in. Many of my students return back after they've got something to share from, the various class learnings or amazing work they are doing out in their worlds. So it's fun for me to just sit there in the audience and, chat with you all. Occasionally I show up in a webinar mode or I give a talk, and today I'm in a very interactive mode. So hopefully, we will drive some conversations. I have posted a quiz in my newsletter, and I do my live stream one-on-one called Sudha Live on Fridays at 6 p.m., which is like my evening here in Silicon Valley, mornings essentially in Asia. And I posted a quiz. And so people were asking questions around that. And I realized that I have done this topic on autonomous vehicle. I've done courses on that before, but the new batch of students who are learning AI are not familiar with the functioning of the autonomous vehicle. So we thought foundational models. So yes, you understand what is foundational models. But my question was, where will you use a foundational model which will take a text as an input and produce an image as an output, like an Imagen or DALI? Um, when you have any such model, how would you use that in autonomous vehicles? And specifically, I said, how will you use that for safety, uh, for improving safety in autonomous vehicles? So there's a lot of questions about working of autonomous vehicles and perception space and all that stuff. So previously, so I teach artificial intelligence boot camp for product and business managers at Stanford Continuing Studies, and my current courses are online because of the pandemic. So we'll go back to campus. As of now, it's online. So I get a wide range of students from every possible country. I mean, no kidding, people are joining from China, from Brazil, from Germany, from California, all in the same place. So it's crazy hours for some of you, so I appreciate that. I've also been teaching AI ethics and AIX design at Barcelona Technology School to multiple different master's programs. It's a master's program college from affiliated with Barcelona University, based out of Barcelona. And I'm doing my classes remote with them. I started teaching out AI ethics, and I specifically focus on inclusive AI. That's my specialty. And Yash periodically joins Barcelona Technology School to teach responsible AI, and explainable AI is kind of her turf. So she comes in as a guest lecturer. Um, but the AV topic in my mind is what I used to cover all the time. So when I talk about AI, I go back to AV as my, or autonomous vehicles as my example. So what we are going to do today is we're going to have a charter session, and I will promptly close at 10 o'clock my time, which is 7 o'clock in Nigeria and Europe, for those of you who are joining remotely, or 2 p.m. in Brazil time. And my goal is to introduce you to how autonomous vehicle technology works. And it is very relevant even now, because just last Thursday, I ended up seeing a whole new autonomous vehicle in Stanford area. And I shared that video, I believe, on Twitter and a couple other places. So I track the latest in autonomous vehicle space, and there is 5 levels of technology. The level 5 is supposed to be where the vehicle can run in all kinds of weather conditions, absolutely with no human requirement. So we are not there. We are all that AV technology is tending towards getting us to level 5. So all the other vehicles that you would see as pilots, we have about 60 plus pilots in California, because it's easy to get a permit to do the pilot, and we are enthusiasts. Also, we let you just, watch us on the road and crisscross and do stuff as autonomous vehicles, like we have other tech out there. So most of the vehicles that you see outside, the delivery bots like Kiwi bots, are at level 3. Tesla is technically not a self-driving car in the technical sense of autonomous vehicles. It is not, but they have built AV technology, so they have enough of AV technology stack. But the normal process when anybody builds a self-driving car is to get a permit from our registry of motor vehicles, and then do a pilot, and it's watched. And I believe Waymo has got out of pilot. Cruise, I don't know if they've said they're out of pilot, but they're driving, been around for a long time, and they're driving and giving official rides like Waymo. Other than that, we see a lot of level 3 or level 4. So difference is, when you're in level 3 or level 4, there is human intervention, which means the car can give control to the human at what is called a disengagement. Disengagement is when the autonomous vehicle gives control to the human. It disengages from its autonomous mode. So the important thing to think about is, in all of those cases, the way it is set up by the companies, KiwiBot is being monitored remotely. There could be remote monitoring in some vehicles, or they could just, the vehicle could give control, and the agency is with the vehicle. So that creates huge, that design implication creates a huge challenge for AI ethics and for human safety when the AI in the vehicle is not inclusive. But that's not my focus today, but I want you to be aware of it as you're getting excited about autonomous vehicles. When I'm going to teach you, today I'm going to focus on the technology of the AV, and I'm going to focus on foundational model, and then have a discussion on how foundational models can be used in autonomous vehicles. So I'm not here to just tell you stuff which you can read from outside. I don't like to teach anything that's already, available out there that you can learn, read and consume information. That's not my style. I want you to think and go innovate, and that's why I have amazing students who go make amazing things, and I'm always bragging about them. Okay, so those of you who are here are people who are on our weekly Wednesday list at Business School of AI. So if you are watching this anywhere, you can join a future weekly wed and get the Zoom link, and it's secure, and there's some community rules of being nice to each other. Other than that, we are pretty open and diverse. So the link for that is bit.ly/weeklywed event. So those are the people who get to answer my questions here. So rest of you are watching on live stream, you can comment, but the people here are the ones who can ask questions. So for those of you who are here, have you seen an autonomous vehicle, or have you, I believe somebody is here is going to be engaged with autonomous vehicles, but I don't know if that's public information, so I'm not going to be talking about that. So have you seen an autonomous vehicle? Yes or no? And you can type your answers here.
Yeah. Yes.
No, yeah. I want chat. I want the answer in chat. Thank you, Suresh. Thank you, Suresh. And I will call on people with questions soon. So, yeah. Okay. Okay. Somebody who has seen it, who said yes. Have you? Okay. So then there is. I see some people who have seen it and some people who have not. So let me do the video. So what I do is I tend to, when I see an autonomous vehicle cross us, I get very excited. The way you would see it is it has a big LiDAR at the top. And we are going to talk about how the autonomous vehicle technology works in a minute. It has a bunch of sensors, cameras, and LiDAR is the main thing, except for the Tesla vehicle. Everybody else has a LiDAR. Tesla runs only with cameras. So that's how you recognize that it is an autonomous vehicle. Otherwise, it would look like any other vehicle, and you would not even notice the difference. So some of you might have seen it. I know in Bangalore, I see some people from Bangalore saying, I'm not seeing an autonomous vehicle. There are a couple autonomous vehicles which are for pulling cargo, which is there in Bangalore, being piloted in there. So I recently saw one that I thought maybe I should share that. And so I tend to, when I see an autonomous vehicle, I tend to take a video of that. That's kind of my hobby. I say I chase it, but I think I'm not really a rash driver. So let me share my screen, and I'm going to start with the most recent autonomous vehicle that I saw. So this is something I took a very quick video as I was driving into Stanford in Palo Alto area. And these two are the two cars I saw, and you can see there's a radar. So when you see a normal car, you see something on its head. That's here. And it's a Hyundai car, so I'm just saying that because of the so it has. So in this case, it's not moving. So what I'm going to do is, as I share I have a slide deck that I'm going to share today, and I'll give you access to this so that you can see more of my content if you want. Yeah. Okay. Let me go back. So what I've done is one of my students did this, Nyan has done this, where we put together a bunch of autonomous vehicle clips that I've collected over a period and made it into a intro video for me. So I'm going to skip my intro part since I've been talking for a while about myself. But each of the cars you're going to see here are real ones that I have collected. So there's a Apple car, there's a Google car, there's a KiwiBot, there is a Toyota one that is an autonomous vehicle from Toyota. I think that is what is in there, if I remember right. So I'm going to share that. Should I make it full screen or is this okay?
Seems
I
fine.
think full screen will
Okay.
be better.
Will be better. Okay. Let me see if it will allow me to do that. Okay, I'm not going to be able to share full screen, guys. So you have to make do with this. Okay. Here we go.
Autonomous vehicles promise to make our roads safe.
I could. Thank you.
In reality, they bring
That's a Toyota
connected
one.
and electric vehicles,
Apple one,
which
old Apple
changes
one.
urban mobility as we know it. I'm Sudha Jamthe. I teach IoT and autonomous vehicle business at Stanford Continuing School.
Okay, I'm going to skip
I
all that.
recently built the driverless world. To truly understand autonomous vehicle business, you need to learn three core topics. One is autonomous vehicle data. What data is collected in the car? What are the three digital twins in the car? And how do you create business value from this data? The second topic is autonomous vehicle business models. Who's going to pay for this car? Is the consumer ownership model going to switch from consumers buying the car directly from dealers to a B2B model where a fleet of cars will be bought by a rideshare company like Uber or Lyft? What will benefit your industry? Come learn the business model. The third topic is autonomous vehicle product management. When you think of autonomous vehicle car cognition, it is artificial intelligence, machine learning based product. And the entire tech stack in our phone is going to switch to the car. What is needed to understand customer behavior and go translate this into customer experience so that you build the product? So you learn data in the car, you learn about business model and product management.
Okay, there comes Rich Schaefer, my student. So I'm going to skip that. So from what you have seen there, where is the AI in the vehicle? So those of you who are here, I want you to add a chat. What AI are you seeing? Are you seeing AI in the autonomous vehicles? Yes, she's saying vision. Okay, so you're using computer vision with all the cameras. Where else? You see autonomous vehicles.
Hello, I'm Rich Schaefer.
Sorry. Okay, interpreting vision, everybody's saying that path planning. Yeah, okay. So when I'm talking about, I have done sessions on AI in autonomous vehicles. So there is all kind of AI in there. So the way the car sees the road is using a combination of sensors. It's called sensor fusion. Cameras, LiDARs, radars, motion sensors, all of them. And earlier I spoke about level 3 and level 4, where the car is driving, but it can, the human can take control. And most of the autonomous features that are level 3 or level 4 are being incorporated in regular cars as ADAS features. So you might not even think of them as autonomous features. So what Tesla is doing is essentially letting the car stay within the road, within the lanes, which is staying within the lane is the basic 101 of autonomous vehicle tech. And then it uses cameras to see that. So that is computer vision. And we'll talk about path planning or how that is done. But beyond that, and today for the scope of our discussion on foundation models and AVs, I'm not going to go deeper into that. But you have voice in the vehicle, you have AR, VR, you have the voice would also bring the text to speech and speech to text. And in the video, if you saw for a split second, I showed that the entire tech stack is moving to the car. So there's a lot more machine learning, looking at data, looking for security gaps between different tech stacks within the vehicle. There's a lot more AI. And I teach this other course. I'm not teaching it live, but we have an on-demand course on that on Business School of AI about data, digital twins in autonomous vehicles, AV data, business models. So all that, if you're interested, follow up offline, or you can go to Business School of AI wherever you've signed up for Weekly Wednesday. If you look at all courses, you will be able to find these courses. And I have some free webinar versions and then on-demand courses. So, but if that's of interest, follow up and I'll give you the pointers. So that's the big picture of all different kind of AI in the vehicle. And we've spoken about it. We know it exists, and more tech stack is moving. So that's happening. But we are here to talk about foundation models, especially how you have text coming in to produce vision output. Okay, so let me go.
I would
Okay. And yeah, let me go back and share my screen. I have a bunch of videos here from various talks, guys. So when I share this, finally, you would get a lot more content. I shared this with my recent Stanford class, so you can have a big picture here. But I'm going to zip through some of them because my goal is to teach you how the AV tech stack works and then tie that to the foundation models.
I would define autonomous vehicle as a set of all businesses that is building the self-driving car technology stack. And it's going to offer some kind of mobility services utilizing the data in the car.
Okay, so let's talk to tech.
AV makers are building the secret sauce is how it takes this understanding of its location where it is and the sensor data, and how is it going to decide, it's called path planning. How is it going to decide the path of where it is going to go, right? Is it going to, now, is it it's not in the center of the lane, does it have to move into the lane? And based on what it is seeing around it, does it have to stop? Does it have to move? Does it have to turn left or right? That, it is all still in the software brain of the car, and that is path planning, right? Based on that, it will do a prediction. It will actually decide what trajectory it has to move in, and then it will plan the route. And then the final piece is where it is drive by wire. It gives control to the brake or accelerator, and then it starts moving. And so that is the normal, the four pieces you will see, the sensing, perception, planning, and control.
Okay, so I want to pause here, and I want to see, so somebody mentioned path planning as the AI in the vehicle, right? Is everybody comfortable about that? Can we move past this? So there is sensors. We were talking about cameras, the LiDARs, radars, GPS, and all of that. All the data is coming. This is the area we are focusing on today. When I talk about how the car sees the road, that space is called perception space. And the one I said that Tesla does that is lane detection. You switch the vehicle to full self-driving mode, and it is actually doing lane detection. Any self-driving car, you put it in the road and you say, okay, let's get started in self-driving mode. The first thing it's doing is the car is driving, right? The first step it is doing is lane detection. It has to localize itself, know where it is, which direction it needs to move, what are the vectors of the moving objects around it, for which it needs to get data from the road, understand that. It needs to identify lanes, which is done by computer vision. It needs to recognize traffic lights. Is it allowed to move or go? It has to do that. That is another AI. It will identify traffic signs, all the different signs, and it is simple classification model on that. then it is doing object detection of everything it is seeing on the road. It even needs to know where is free space in the road, where it is allowed to move. That's how it can do that. All that is perception space. There are several companies in this space. The new companies that are all coming in the AV space are all doing this, some aspect of it. And they're all doing some aspect of computer vision, essentially, or some kind of models that will identify some element in the road. And doing this right is what is going to keep the vehicle safe. And then you do the planning and say, okay, now we've understood where the road is, where the lane is, where the vehicle is, in which direction is the vehicle facing, what is the vector of the objects coming. And then it is going to do the route planning and whether it has to move in a trajectory and all that stuff, right? But and then the behavior of whether it needs to hand control to the human, it turns it blinkers on and all those things. And essentially it is doing prediction at every step, and then gives control to the vehicle is this last piece. So talking of perception, so I want to pause here. What do you think is the biggest challenge if you were involved in building this AI? So we've spoken and done a lot of AI classes before. There is a lot of reinforced learning in building this models in the perception space itself. So essentially they drive the car and they are going to see us, and we are the objects, we are the data. It's with all the cameras, it's seeing the videos, and that becomes a computer vision input. So what do you think is the biggest challenge for security to build this right? What is the biggest challenge for security? And Suresh, if you have a question, you're allowed to speak up. It's totally fine. It's not going to interrupt the flow now. Interpreting vision for the next move. Okay. Training with massive amount of real world data. Yeah. Anybody else? So when you're saying interpreting vision for the next move, you're saying prediction of the next move of what the vehicle should do, right? That's what it's doing. It's interpreting vision for understanding the lane, and understanding free space. It's understanding vehicles. It's constantly doing object identification, right? It's doing, if you're a computer vision person, there's a lot more complexity, but the vehicle, the way the car sees the road, we simplify this and say object recognition, and we say, hey, this is a car and this is a tree, this is traffic light, use classification model for traffic lights. But the reality is all of this is coming together. So that's a very good point, that interpreting for the next move, because constantly it's moving or it is stopping, it is making a decision whether it should accelerate or decelerate or give control back to the human. So everything is, I'm guessing that's what you're saying as next step. It's constantly predicting, and that's the whole brain of the whole perception module. But within that, what is the biggest challenge? One is getting a lot of data. Somebody said that, right? Understanding human and property. Yes. The biggest challenge is there are humans in this case, right? There's humans crossing the road, and we are unpredictable. I shouldn't say they and sound like an alien. We are very unpredictable. So initially they used to use training data, videos and stuff, and try to create simulations. And we have big simulation engines and test beds where autonomous vehicles are tested before they come out into the public, where you see it at the pilot stage. But the biggest challenge is humans are erratic compared to in the expectation of the vehicle in terms of being very predictable. So there have been accidents because it was trained for a certain situation of humans and cycles and animals crossing. And there was an unfortunate Uber accident where a person crossed the road walking pulling their bike, and they had some bags on it, so the shape of the bike looked different. So for the car, it was a huge challenge to see a human a bicycle, understand the shapes of it. Still, if they see a moving object that is coming across from them, they should stop. So it was the fault of the Uber. The other thing is there was a Tesla accident where they fixed this, by the way, but there was a truck that was crossing, and the car saw that as a bridge and tried to go under the bridge instead of, stopping a collision with a big truck. So there's a lot of challenges in there. So the biggest thing is getting a lot of training data, all kinds of situations, and unpredictability of humans is the big thing. And how about training for that is the big thing. And from a computer vision perspective, you're not just seeing the dog, the person, the road. It is a multi-layered approach. So you have the human crossing in front of another vehicle, and from the car's perspective, it's going to see multiple layers of vision. And so understanding what is in front of what is, and if you remember when I said this, I said, what is the vector of all the objects? It's not looking whether there's a static object. It's not interested in static object. It's if you're in the road, and if you're on the side of the road and you're just, not going to cross and standing, it doesn't bother it. It just sees you as a static object. So there are some perception technology companies who are looking at the people on the road and trying to see whether you're sitting with your cell phone and you have like your head is down, and they are making a prediction whether you're going to move and cross the road or not. So they're predicting your next move instead of predicting the move of the car, to see whether you're going to become an obstruction on the road that the car needs to stop for. So there's a whole company from Boston which just does that prediction of humans. And I am not going to go into the AI ethics of it, but I want you to be aware at every step, it is invading privacy of people. It is not understanding if it is not understanding everybody equally on the road, it is going to create issues with that. So the next step of it, I want to tell you about sorry, I'm just going to tell you about the tech stack. 1 second.
See, I put this as AV technology.
All that
at
we
the
spoke
bottom.
is AV tech.
And the car makers don't have this technology. They're either investing in companies doing that, or they're partnering with companies. So in Waymo's case, they have a bunch of Chrysler minivans that are using Waymo technology. So, it's a purchase from Waymo of Chrysler cars, and then they retrofit it with the AV technology. So they have to put all their sensors, and then they actually do the sensor fusion and then their AV inference model. So there's a whole bunch of ride share companies like Uber and Lyft who are saying, hey, we are working on autonomous vehicle technology. And their play is, again, it's some select set of OEM car models where they're doing this. And so those three players are the main companies that you would see. So
Okay, so one update is officially Uber has got out of building the autonomous vehicle technology to create a vehicle to run as a Uber car or a Uber truck. They've officially exited that space after many accidents. But every company is using machine learning from the data in the vehicle. So Uber has, I believe, AV tech, but not as AV tech for perception.
So from a tech stack perspective, there is the AV technology, which is the car cognition and sensor fusion piece that we saw. And then the car makers, for this to be able to work with the car, they need to wire it back, right? Can we just put a piece of technology on our car, on any car? So they are wiring that so that it talks intuitively, right? So that is the piece the OEMs have. And then the OEMs are building out one more piece, which is called mobility platform. We'll get to that in a minute. So the rideshare companies are also building similar AV technology. So today that's what they're doing. But the rideshare companies have this platform piece, right? They know to map the drivers who are ready to take a ride with the passengers who are ready to go on a ride. And so the general belief in this whole AV space is that the business model that is going to drive the AVs to take off and scale is going to be some kind of shared model. It could be car sharing, it could be ride sharing, it could be mobility services to build on top of it, which involves some kind of sharing of that car, so that you can optimize the utility or the usage of the car, so you can bring them the cost of miles spent. That is the key metric that they work towards. So that the platform is what is needed finally. So if you see, each of these players have one piece of the tech. So the car OEMs have the car, the AV technology people have the software stack, which will make the car run autonomously, and a bunch of sensors to see the road. And then the rideshare companies know the mobility piece. Eventually, all three has to come together. So everyone, when they deploy this and say, hey, we are going to run robotaxi, that is what they were going for. So that model is shifting, and we are not seeing them bet towards robotaxis. So that's a different discussion, why they are shifting away from that space. But coming back to the tech stack, that three pieces of tech is needed. So the drive-by-wire that the OEMs have, in fact, the OEMs also have digital twins, which is creating a digital replica of all the car parts. And then these three pieces are needed to come together, whoever runs it. So that's why you would see a lot of partnerships in the space, a lot of partnerships and some breakups and investments that's happening. And so far, we are still talking about the AV technology companies running with regular cars, or the OEMs running with AV technology in some kind of partnership, or the rideshare companies making their own AV tech, again, working with some kind of OEM cars, right? So that combination is what we have today in every single pilot in what we're seeing. A new set of companies are evolving who are saying, hey, we need to build this car as a ground up new thing. Like wise Tesla talked about all the time, is they created that car. It's like a Apple iPhone that they own the entire stock. So they will be the entire stack, right? So they will own all the different sensors, so they can manage it. In fact, they were using NVIDIA's chip, and then they said, no, we made our own chip. And they are using their own chip in the car, which can manage this whole communication between the intelligence in the car to the cloud, where it will do more processing. And so the connectivity to the cloud, how that payload is managed, and the edge intelligence, all of them become pieces of that.
Okay, so I want to pause here, guys. Now let's come back to the foundational models we talked about. So can somebody give me a foundational model that we've covered in the last week? Give me an example of a foundation model that we covered. Okay, name of, thank you for that. So give me a name of it. Imagen is one. Imagen is from Google. What is the other one? DALI is there. So
so if you see, I put this as a.
Sorry, it's just trying to talk by the side. It's like an autonomous vehicle with a mind of its own. So the thing with foundational models is that's the latest, greatest in the research side of AI, where the entire Wikipedia has been fed to train natural language models. So here is DALI. You will see a lot of DALI example of the avocado chair. So you give a text and it produces the output. It generates the image. Or previously we had this GPT image where you give the model input would be part of an image. So if you give this, it completes to the full image. Here is half a cat, and it shows a cat, and it's, you know, with various different aspects of it. So filling that is, you know, is understanding context, what's a big deal. And typically when you see foundational models, the one thing you will see is called Hugging Face. These are transformers, or you will see GPT, and GPT-3 is the big one, right? They are focused on language, right? So the big thing with the foundation models, other than their claim that they're built with all possible data out there in the world, is previously we had NLP, natural language processing, which was about text and understanding of text. And now, and then we had computer vision. All that we spoke about perception space was about computer vision and understanding the images and videos in the space. But the set of foundation models are essentially about generating new content. They've consumed a lot of content, huge volume of content. That's how they were trained. But they're doing two things. One, they're generating new content, they're generating new images, they're generating new text and language, not previously done. And of course, there's another side that leads to fake images, fake text and fake voice and all that stuff. That's the other side of tech. That's why you cannot learn any of this without understanding the ethics of it. But what I was showing you with DALL-E is it is taking text and producing a vision output, computer vision image output. So for the first time, there is a movement with all these foundation models to combine the world of language, which is natural language processing, to the world of images, which is computer vision. And so it's taking text and producing an image. So that is what I promised to get to today. So I'm still not going to give you the answer because you wanted the details of this. So we spoke about how the car sees the road, the perception space, the 4 paths of getting to path planning in the tech stack. And we went in deeper with the perception space, all the different aspects of the perception space of how the car would see, understand the lane. In fact, if you go to Business School of AI, where you signed up for Weekly Wednesday, I believe there is a free course where I have collected a bunch of data sets for autonomous vehicles and that was used in different competitions. There's a Berkeley set, which is about identifying lanes. So if you're interested, if you're a newbie in computer vision, you can play with all of this so easily. So typically the perception space is all about vision. You all said that right at the start, right? And I think somebody here, I think Radhika was saying it's about predicting the challenges and predicting the next step of what the autonomous vehicle should do, what action should it take based on all the information it is getting. And it was all computer vision centered. And then we spoke about various different AI in the vehicle in making the tech stack run. So the safety of the vehicle. So my question is, what kind of application can you build using a foundation model like DALL-E or Imagen, where you get text as an input and it produces image as an output? And all we saw so far is the autonomous vehicle is trained by images. The autonomous vehicle is trained by videos. It runs pilots, watches us. It needs to recognize the free space. It needs to recognize lanes. It needs to recognize other objects with all their vectors. It needs to identify traffic lights, other road signs. All of that points to computer vision, image identification, object identification, right? And then I spoke about how the object identification is not individual objects as lanes and trees and shrubbery and other cars, but the combination of it when it is moving dynamically and the layering of that information. So again, it is still computer vision. So far, the realm of autonomous vehicle perception is focused on computer vision. It has not come to foundation models. It is purely in computer vision, where it has other AI. It has voice in the car. It does text to speech, speech to text, connecting to the cloud, running digital twins, and a lot of machine learning to look at the data in the car, all those things, right? So those are all different AI that you have in the vehicle. So I'm going to come back to now. Here we have a whole new set of foundation models. And if you are new to foundation models, we just covered it a couple weeks back in Weekly Wednesday. So if you sign up for Weekly Wednesday, you'll get access to our past archive. Or if you get to my newsletter, which is bit.ly/Jamthe newsletter, you'll find the archives even without a sign up. You can learn foundation models. And I would recommend foundation models because foundation models also are coming. Again, all the tech companies are always competing with each other. So it's very unfortunate that you don't see so much collaborative work on standards and stuff. So you're seeing Imagen from Google competing with DALL-E, which is from OpenAI, which is owned majority owned by Microsoft. So there's competing models. So you have to pick one API and build on it, but you have the option of building on it. So one of my work is about language models, working with language models from various different parts of the world. And so I have a Global South language model meetup that I'm working with multiple different groups, working on GPT-3 or BERT, or NLP for various non-English speaking languages from Africa, from Latin America, from Asia. And that has been a separate world. Then all that we spoke about today was perception space, computer vision in various different forms in the vehicle. So now that brings us back. So I hope that's helpful to understand how the car sees the road, what is the tech in terms of computer vision and images. And that is what keeps the car safe in doing this object identification and prediction. Next step prediction for the car on what it needs to do is what the safety of the car is all about. Now my question, and you've learned that the foundation models are generating images and generating text and taking text and generating images. It's all about generating new content. Okay. And so now my question to you, and I want to get answers from you, and you're welcome. I'll give you a week's time if you want to come and press, share this. I'll give you by next weeklywed, or reply back to me on my newsletter, or find me on LinkedIn. That's fine, or find me on Business School of AI. My question to you is, and all of you are innovators. That's why you've been taking my classes. What kind of innovation would you create? And if you don't want to put this in public, that's okay with me. My promise is, if you have an application idea, I will take you to any of the autonomous vehicles that's here in California that I'm aware of, because I have my students in many of them who would love innovation and innovative ideas. So my question is, what kind of innovative application can you build to improve the safety of autonomous vehicles? What we spoke about, perception space, how the car sees the road, how it has the challenge of training with a lot of data, how it has the challenge of predicting the next step of what the AV should do. How can you build an app of any kind, or an application layer of any kind, a piece of tech? But I'm thinking of the application layer of it. It's not just technology, okay? How can you do that? By taking foundation models, which are generating new images, generating new text, in this case, specifically taking text and generating an image. How can, if that DALL-E or Imagen is given to you and you bring it to the autonomous vehicle, what would you do? That is my question. That is my quiz question to you. And I've now extended this for week 3, I believe, right? Because I want to give you the time to think. It is very easy to get excited about autonomous vehicles and chase the cars like I do, but very easy to think of it as, let me understand the tech of it. And this is path planning and sensor fusion and all that stuff. And you don't need to give me the answer right here. And if you think you're going to go build something with it, that is fine. So you could say in the car, I see a comment, I see an avocado chair, and the car can respond with a yes or no. Making sense of nonsense. That's a good imagination. So hopefully the car would never see an avocado chair. That's why I was happy when Imagen said that from Google said, hey, we are creating photorealistic images. We are not creating avocado chairs. I think it's a huge technical feat. I keep laughing about it, joking about it, but to say that you create a chair which is made of avocado and create it that looks like an avocado is a huge technical feat. So I would not underestimate the power of what DALL-E has created, right? You give a prompt, a text prompt, and it generates an image. So an avocado chair. Think of this. This is actually cool design, right? Though you think it's avocado shape. Think about it. It's 5 different things. It's beautiful. But avocado chairs are not real. They're not going to come in the middle of the road. And that's not the challenge that autonomous vehicle is facing. It is seeing us as humans. And this example I gave you with the Uber accident with the person walking with the bike, and they had bags. And this unfortunately was, a homeless person. So they had all these bags hanging on the bike. and they were crossing the road. So the human was crossing, there was a bike crossing. They could not recognize the shape of the bike because of this, and it all put together, and it confused the vehicle, which is very, very bad. But the challenge of the unpredictability of the human, enough training data, those are all my clues to you. So I'm glad you all responded to all my prompts here. So I'm going to leave you back with the quiz. Now that you've understood foundation models, especially DALI, if you want to see that back again, I will show that to you. Takes an input of a text, any text. And I believe Yash did an image in demo. And you saw that, was it last week or last to last week, Yash? In Weekly Wednesday? Yes. So at a broad level, we need training data. So that's all good. But think about it and talk to me, because I'm going to take you to the autonomous vehicle technology companies to go make this happen. If you have a specific idea that they will listen to you and they will go incorporate that in the tech stack, I'm going to take you there. So we are using content, and you can say foundation models are all generating content, and we can use that for training. But I'm looking for a specific use case that's a very good point, that you can generate more and more content. And that's what the simulations are doing. There are simulation environments which are generating imagery, videos, all kinds of setup of people crossing in different situations that the cars are trained in, that exists today. So the GAN created images, right? So it created new images. So that is already used in creating training data. I'm specifically talking about foundation model where you take text as an input and produces images and output. And how will you use that to improve perception safety of autonomous vehicles? That's my quiz. So with that, I'm going to wrap up. Find me with your answers, or if you don't have an answer, ask me if you have more questions so I can help you understand this space better. I have a specific application in mind. And that will help prevent a specific accident that happened in the past. And if you want to go Google it, there was an accident where the car could not see. There was a fire truck that was reversing in the road. So in that case, I believe that applying foundation models into AI, AV perception is going to help. That's a bigger clue than what I've given so far. So with that, I want to wrap up. I will see you all next week, and I will see you at Sudha Live on Friday for those of you who will be joining me times zone sense wise. Otherwise, I'll see you next week. And we have a fantastic speaker. In fact, we have a couple speakers lined up for next few weeks. And we have Professor Tiago Felipe Avanci from Brazil, who's going to be joining us as our speaker at next Weekly Wednesday, and Yash will be back hosting it. So I hope to hear from you all, and share your innovations and share your answers on this, or share more questions, because your real superpower is to ask the right questions. That's what seeds foundation. That's what seeds innovation, and the foundation models too. Okay, with that, I'm going to wrap up. Thank you, everybody. Stay safe, and I will see you next week. Bye.
Thank you, Sudha.
Bye.
Thank you, Sudha.
Those of you who are watching this live stream, hope you'll come join us. bit.ly/weeklywed event will get you to weeklywed, where you can be one of these people here. Join my students out for the Zoom. And I hope to hear from you and cheer for your innovations and